Okay. So the next thing is set. So the other things that we mostly use in microeconomic theory, or either in general in economics, is set. What is set? Set is a collection of elements, and elements can be anything. In terms of notation, for example, when we write down X as a capital letter, X is a set of X, one, for example, up to Xn. Again, X1 up to Xn can be anything, just element. X1, X2 up to Xn can be anything. So we can either use S, P, S, T, Q, but mostly we use the capital letter. But for the element, we use small letters. For the name of the set, we use capital letter, but for the element, we use small letter, X1 up to Xn. Okay, we already covered that when we say X is an element of, X is an element of X, or X is n X. It can be X1, X2, X3, or when we say X is not an element of X, X is not an X. X is not an X. We use this notation to show that an element exists in the set. We show this notation that an element does not exist in the set. Another thing is descriptive of set. So we can describe set by this notation: X in X big letter, such that, for example, a statement about X. For example, this is a set of X. An example, for example, X is equal to X in X such that X is less than B greater than A. So this statement about X becomes like this: X is less than B and greater than A. So we describe set by this way: X is equal to X and X. This is element, this is the name of the set, such that a statement about X. A statement about X can be anything. For example, the statement about X, it can be X and X such that X is equal to the name of all the fresh fruit. Or as X is less than B greater than A. Then we write down the statement. 1, 3 is the subsets of real number. Subset of real numbers. Subset of real numbers. For example, we have this sign. It's similar to R, but not exactly R. This sign means real numbers. And it's equal to, starting from negative infinity up to positive infinity. But it does not include, because it's closed. It does. It's open. Sorry, it's open. It does not include negative infinity or positive infinity. All numbers between these two, between this negative infinity and positive infinity. And also, we call this one as a open interval. And this one, R negative, it starts from negative infinity but does not include negative infinity up to the 0. So we can write down by this way. X is in real number. X is in real number such that X is less than and equal to 0 greater than negative infinity. Less than and equal to 0 greater than infinity. It's called just non-positive real numbers. We cannot say this on negative real numbers. We just say non-positive real numbers because 0 is not negative, it's not positive. So that's why we can only say non-positive real numbers. And this one, R positive, is a start from 0 up to positive infinity, but does not include positive infinity. We can write down by this way. X in real number such that X is less than positive infinity or infinity, but greater than and equal to 0. It's non-negative real numbers. It's non-negative real numbers. And also this one, or negative. Or negative. It's from negative infinity to 0, even does not include 0. So we can write down X in real number such that this X is less than 0 greater than negative infinity. It's negative real numbers. Negative real numbers. Or sometimes they call it strictly negative because 0 is not included here. Negative real numbers. And also this R with 2 positive sign. That means strictly positive real numbers, which include from X is a set of real numbers. X is a set of real numbers such that X is less than positive infinity and greater than 0. Less than positive infinity and greater than 0 is called strictly positive real numbers. Because this set does not include 0. The other notation that we use, for example, for any A and B, which are sets of or included in real numbers, such that if A is less than B, if we have this kind of notation, for example, A and B, it's called open interval, which does not include A and B, but it's include any value between A and B. And we can write down by this way that X is in real number such that X is less than B and greater than A. That means it includes any values between A and B, but does not include A and B themselves. And also when we have this notation, A and B is called closed interval. In closed interval, include both of the boundaries. That means X is a real number such that X is less than or equal to B and greater than or equal to A. That means it include all the values between A and B and include themselves as well, A and B. Include A and B as well. So it's closed interval. And also we have this one. We start from A and close to B. Or we have this one. A is closed, but here is open. In both cases, we can say either semi-closed or semi-open interval. Semi-closed or semi-open interval. In this case, the first one, which is we have like, it's include B, but does not include A. We have X as a set of real number such that X is greater than A, but less than or equal to B. It includes B, but does not include A. Here, X is a set of real numbers such that X is less than B, but greater than or equal to A. This too called semi-closed interval or semi-open interval, but this is closed interval and this is open interval. It's fine. And also another notation that we use is this one, N. But not exactly N. It's a something similar to N. It's natural numbers. In microeconomics, we use sometimes this notation. N, like capital N, but not exactly N. It's a set of natural numbers, which is include from like 0, 1, 2, up to any natural number that we have. And also we have this notation, similar to Z, but not exactly Z. It's integers. Set of integers, which this Z is equal to, starting from negative infinity up to -1, 0, positive 1, then up to positive infinity. Sometimes some people include 0 into natural numbers. Some people just start from 1 to positive infinity. But here, when it comes to integers, integers include from negative infinity up to positive infinity. Then we have set of rational numbers. Set of rational numbers, which can be written as a Q. This kind of Q, but not exactly Q, is equal to any X in real numbers, X in real numbers, such that there exists like element A and B and set of integers where B is not equal to 0 and X is equal to A over B. So rational numbers is like real numbers is a set of real numbers. Is a set of real numbers where we can write as a ratio of two integers. A set of real numbers where we can write as a ratio of two integers. But with one condition, that b should not be equal to 0.